Okay, so hello everyone. Welcome to Customer Segmentation with Python and Kaggle. My name is Laura, and let's get started. So coming up today, there are a couple of things that we want to cover today. I will introduce myself first. I will talk about some objectives that you might have when you segment customers. I will talk about where to get data sets from, what to do for exploratory data analysis. There will be a little bit about pre-processing, and then as the title says, there will be something about features and segmentation as well. So just to briefly introduce myself, my name is Laura, and I'm a marketer based in Seoul in Korea. For me, coding is more of a hobby. As a person who works in marketing, I do enjoy my job very much. So it is a bit creative. It's a little bit analytical. Every day is a bit different. So with this meetup, you might say that I am combining my work and my hobby. Now, just to think a little bit about our objectives for segmentation. So when you start segmenting your customers, your audiences, you may want to think about what you're actually trying to achieve. Why are you doing what you're doing? What's your rationale? And for example, you could think about whether you want to get a picture of your current customers. Maybe you would like to find out why you're losing customers. What are your lost customers like? Or perhaps you want to predict future customers. What do these people have in common? For me personally, for this meetup, my objective was to find out more about where and how businesses lose customers, and that is what I'm going to focus on. Now, just to talk briefly about data sets. Data sets can be sourced from a variety of sites. So for example, there's Kaggle. It has an API, which is what I'm using for my meetup. We're going to have a look at that in a minute. There is a handy little feature called Google Dataset Search. Some governments have publicly accessible data sets. There is the UCI machine learning repository. Back in the days, there was something called 538, but apparently it's gone defunct as of last year. And then there's also open data on Amazon Web Services. And these are all good sources, to be honest. Now, if you just want to explore your data set, so generally you just want to find out what data am I actually dealing with? Is my data complete? Are there any outliers? Are there anomalies? What are the data types? Is there any missing data? Are the data types correct for that category? That sort of thing. And we're going to look at that in Praxis in a second. But then some options that you could look at would be if you look at the head, and by default, it's the first rows of data. If you add a little number between the brackets, it'll give you however many rows in that data set are for the first couple of rows. If you want to have a look at data types, at number of rows per column, at column names, that sort of thing, you can use info. If you want to find out about your missing data, is my data set actually complete? You can use isNA.sum, that works. And then if you want to go in a little bit more detail, you can select your column individually and you can look at the value counts. And what that does is it looks at the values in each column and then how often these values occur. And lastly, one which I find really, really useful, it is describe, and it has a bit of summary statistics, if you will. It has minimum, it has a maximum, it has quartiles, it has standard deviation. And again, we're going to look at that in a minute. Now, if we want to do some pre-processing, some cleaning, if you will, and you want to prepare your data set once you've explored it a little bit, a couple of things you can do is, if you have missing data, you can, for example, put in placeholder values. You can get rid of outliers. You can also predict missing values. There is a model called iterative imputer, and there is also something called resampling. So in my case, I actually had to resample, and I will explain why in a minute. It's really cool. And then if you have categorical variables, Again, we're going to look at that in a second. We can use something called one-hot encoding. We can use where you create a new binary variable for each category if your data is non-ordered. And if your data is already stored as a category, you can do something called label encoding. If you find that your numerical variables are really all over the place, what you can do is you can scale them in order to fit them and to make them more comparable. So apparently, if you work with machine learning a lot, and you want to train a model, that is something that is commonly done just because it is so useful. Now, let's talk about marketing for a minute. And if you look at segmentation, there are quite a few things that you can do. So, for example, you can segment your audiences by demographics, by user behavior and customer lifecycle stage. You can look at interests, you can look at psychographics, you can look at the device and the platform that your user is coming from. You can look at lookalike segments, and you can also create custom or mixed audiences. And let's have a look at these individually. It's so interesting. So for example, if you want to segment your audiences by demographics, that is quite basic. So for example, how old is my customer? What gender are they? What location are they in? What's their education like? What's their income level? And as an example, let's say you are maybe a whiskey manufacturer, then obviously you wouldn't be targeting people under 18, as an example. Then another thing you can do is user behavior, customer lifecycle stages. And that is something that I see a lot. So, for example, you will look at, has this customer actually visited my website? Did they stay on the website for how long? Did they sign up maybe? Did they register? How many websites did they visit? How many sites within my page did they visit? So let's say, for example, I'm Netflix and I am a streaming platform, and then I have a customer who tried maybe a free trial for a month, but then didn't end up paying. So then I may want to target this person, kind of like a retargeting, and say, hey, we're going to give you this ad because it looks like you have engaged with our website before, but you didn't sign up. So let's try and get you to sign up for whatever it is. Let's try and turn you into a paying customer. Then there is also something called interest. So let's say you would like to, let's say you're a car manufacturer, right? Let's say you are, okay, what's a Korean car brand? Let's say you're Hyundai and Hyundai car, and you want to sell more cars to people. So obviously you're going to target people who have an interest in vehicles, in sort of motor vehicles, motorcycles, that kind of thing, right? And you can do that by looking at searches, at shares, at likes, okay? That kind of thing. The next thing that you can segment your audiences by are psychographics. And that is something that's a little bit deeper. It's a bit more personality and lifestyle based. And things that I've seen on certain digital platforms are things like, for example, somebody's getting married soon, somebody is classified as a thrill seeker, somebody is classified as a value shopper, or somebody is maybe somebody with a friend whose birthday is within 7 days. And let's say I want to push a certain product, then I can engage these if it matches my product. Next thing you can do is you can look at devices and platforms. So for example, is somebody using Apple? Is using somebody an Android device? Is somebody coming from a mobile device, sort of phone or a tablet? Is somebody using their PC? Is somebody maybe on internet TV? Is somebody coming from a text or an email or an app notification? These are all things that you can use to segment. Then there's also something called lookalike audiences. So lookalike audiences are people who have characteristics that share characteristics with existing customers. So maybe you want to look at these people and say, okay, you are similar to my existing customer. I'm going to serve you this ad. And then lastly, there's also something called custom audiences. There's also mixed audiences. So for example, let's say you are let's take the whiskey example, okay? So let's say we're going to take somebody who's over 18 and somebody who's maybe in the country that I'm distributing my whiskey to. Okay, so we're going to use age, we're going to use location. And then let's say we're going to want somebody with a sort of psychographic segment. So let's say I want somebody who is into nightlife. Okay, so somebody who likes to go out. Then we can mix all these. And there's even the option on some platforms where you can make your own audiences, where you can target people who have maybe searched for certain words, maybe people who have installed certain apps. You can also make custom audiences. It's so interesting, really. Now, just to quote my sources before we look at the practical side of things. So I have used some of my Codecademy course notes, and for that I have physical notes. I also have a Notion where I take notes in, and I use these. There's also a Forbes article about customer segmentation. There is a dataset from Kaggle. We're going to look at that in a second. There is something about ways to evaluate features for feature selection, which I found really helpful. And lastly, for some of the graphics, for some of the images, I used this website here, Aussie Meat Pies, because I found them quite useful. Now, let's get cracking with that data set. Let me just bring that up 1 second. Let me just have a quick look if there are any questions. No, looking good. Okay, just 1 second. All right. Okay. Right, so let's get started. So here's the banner, customer segmentation with Python and Kaggle. And so the first thing that you can do is you can go onto a website that you like and you download a data set. And in my case, I picked this one. Okay, let's just copy that link and let's pop that in the chat as well. Okay. All right, and then the interesting thing is, so of course you can load that data frame onto your computer if you wish, and then you just read it in via pandas. And then what I found over time, as I amassed more and more data sets, I found that I didn't really need these data sets. I found it a little bit annoying. And so I wanted to keep my machine clutter free. And what I did is I had a look at the API that Kaggle serves. Okay, let's have a look. So basically what you do is you install open data sets. So it's down here. Some of the libraries that we're using today. And then we're also going to install pip install Kaggle from your terminal. And let's have a little look here. So the libraries that I'll be using are pandas, there's matplotlib, there's OS, there's open datasets, Seaborn, NumPy, and then there's a little bit of pre-processing as well. So once we've got all that done, what you can do is you go into your Kaggle dashboard, then you say settings, API, create new token, and it downloads a little JSON file for you, basically. Okay. So it says here, create new token. If you don't want to use your token anymore, you can also say expire token. That is really useful. And then once you have that little JSON file in your downloads, you go to your Python environment site package. We got a little spelling there. Let's fix that right now. We go into our little Python environment site package, and we copy that JSON file over here. Here's our little JSON source file. And then what you do is you define your URL where you want your data set from as a string variable, and you download it. Okay, so we've done all that. Let's just have a look. And then what it does is, once you do that, it's actually asking you to add in your Kaggle credentials. And again, these are in your little JSON file. You input your username, which is my name, and you input your password, and then you're basically set. I'm not going to show my password for obvious reasons. And you create a directory from URL. You list that directory, like so. And then you read in your CSV just as you normally would. If you have a little quick look around, you can see your columns and you can see some of the data, the first 5 rows by default. Okay, and in this case, it's worked. Yay, good news. And then we can proceed. Okay, and then what I found was that some of the column names were unnecessarily long and I found them sort of difficult to navigate. So what I did is I renamed some of the columns. And then what I did next is I checked whether the data types seem to generally match the column names. Okay, so we have objects, which are strings. Then we also have integers. So these are full round numbers, and we've got float numbers. So these are continuous numbers, basically. Then if we look at info, we can see there is no data missing, which is really useful. And then if we look at summary statistics, we have the amount of rows, we have a mean, we have the standard deviation, we have a minimum, we have the 25th percentile, the 50th, and the 75th percentile, and we even have the maximum values as well per column. So just to give you an example, so we have more than 10,000 rows. The average age of the customer is about 46 years old. Standard deviation is 8 years old. So generally, most people are 46 plus minus 8 years old. The youngest is actually 26, the 25th percentile to the 75th percentile. So here, that is, as you can see, basically our 46 years old plus minus 8 years. And then the maximum, the oldest customer that we have is apparently 73 years old. And moving on. Again, I wanted to check, can I really be sure? Are there no rows with any values missing? It does not appear as though there's data missing. It's really cool. And then I actually wanted to find out, because I didn't understand some of the values, and so I looked at what actually each column means, and I found that some of the columns were not really, they're not really relevant. So what I did is I dropped the ones that I didn't need using df.drop, and I dropped them in place, meaning that I'm changing the data frame in place. And just to make sure that everything's worked, I've had a quick look. What are my column names? And these are actually all things that I'm interested in. Okay. And like I mentioned earlier, I was interested in finding out how do my existing customers differ from my attrited customers. In this case, attrited means lost. Okay, so we've lost these people for whatever reason. We don't actually know, is that person dead? Has that person simply changed banks? Is this person only lost, if you will, temporarily? What's going on? Is this person maybe on an extended holiday? We don't know. It's just, as far as the bank is concerned, this customer has been lost, basically. Okay. And then I just had a quick look. So for example, what are some income categories? And it looks like the largest segment is actually people making less than 40,000 annually. And then the next biggest segment is people earning between 40 and 60,000. And then it goes down a little bit. And then the highest earners are actually in the vast minority. Okay. Then we have a further little look. Okay, so what cards are actually available? And it looks like the standard card is the most common type. There are a couple of silver, gold, and platinum holders. But compared to the blue holders, they're quite a fraction, quite a small fraction actually. Now, the next thing that I did was when I looked at the attrited versus the attrited versus the existing customers, I found that there are a lot more existing customers than attrited customers, which I guess is good, because if you have more lost customers than existing customers, you might want to get worried, I guess, as a bank. So what I did was I had to resample. So that is a bit of my pre-processing, if you will. So let's have a look. So I created a little mask. Okay. So I divided my data set into existing customers and attrited customers. Okay. And then what I did is I resampled my existing customers, and I only wanted to have as many existing customers as I have attrited customers, and I want a random sampling. Okay, so that's done. And then next thing was I wanted to go by feature, and I wanted to look at quantitative, and I wanted to also go by categorical features. Okay, so the first one that I looked at was discrete quantitative variables. So these are integers, but they're not ordered. So for example, customer ages, the number of children, how many months are these people on the books? So how long have they been a customer? Have they been active? Have they had any contacts recently? What is maybe their transaction count? How many transactions have they had in total? And let's have a quick look. So here, because I'm lazy, I just used a little loop. Okay, and so for this item in this list, please make me a little graph. Okay, and existing customers are this beautiful little turquoise color, and lost customers are these little magenta colored people. And let's have a look if there's any big differences. And because I have resampled them, the lost and the existing customers are actually comparable because I have the same amount of people in each. Right, let's have a look at the customer age. So generally, yeah, the distribution seems to be relatively similar, nothing really crazy. We have a few more people who are sort of around 40 who are lost, and then we have a few more people who are in their early 50s, but there's nothing really that sticks out too badly, I guess. And then the amount of dependents, I'm assuming that includes children, is also quite similar for each customer group. And then here's the interesting thing for months on the book. So how long have these people been customers? And what I would maybe want to find out as a bank. So it really looks like at some point, maybe 3 years ago, there was a big promotion, or maybe there was a big change in the environment, and a lot of people seem to have signed up around that time. So I would maybe check what happened there. Did we run a promotion that was really successful? What's going on? Because we just have so many customers who have been with the bank since that time. And then let's have a look. Okay. Then we want to look at these customers, these lost customers versus existing customers. How do they fare? And what we can see is most active customers have been active within the last month. Okay, excuse me. And then as soon as we have inactive customers, if they have been inactive for more than 2 months, it really looks like that's where we're losing people. Then again, if we have a look at the amount of contacts that customers have had, so generally it looks like the more contacts, the more they're likely to be attrited. And I'm thinking maybe that means if they wish to close their account, they would contact the bank, right? And maybe they might even be contacted, or they might be active in contacting. Maybe that's where we get the high numbers from. That is maybe something for the bank to investigate. But generally, if they're attrited customers, it looks like they're getting in touch more. So maybe there's something to follow up. Maybe there's an account to close, that sort of thing. Now let's have a look at transaction counts, and this one is a bit of a duh moment, I guess. So if we have a lot of transactions, it looks like these people are more likely to be existing customers. If we have less transactions, it seems that they're more likely to be lost customers. So, I mean, if they're lost customers, they cannot perform transactions, right? It makes sense. Okay, all right. Then there's also categorical data. So, for example, the gender of that person, the level of education, the marital status, the income category they fall into, and the card category they have. Okay, and again, I have a little for loop here because I'm lazy. I guess some of these need ordering, but to be honest, we can still interpret the graphs. So let's have a look. If we look at the gender, so it appears as though there are more female customers who have been lost than men. And if we look at the education level, and let's kind of go from uneducated. So there's a lot more people who are uneducated, so at the sort of lower end of the spectrum. But then there's also a lot of people where we don't know the data, or where they have very, very high levels of education, where they have a doctorate, or maybe they're postgraduates. And there are also more people who have been lost amongst these extreme ends of the spectrum, if you will. Whereas people who have gone to college, who are maybe graduates, who have completed high school, they are more represented amongst the existing customers. Okay, so more kind of middle of the road people, they seem to be more likely, they seem to be more common to be an existing customer. Okay, all right. Now let's have a look at marital status. And for married people, the numbers seem to be quite similar. For divorced people, the numbers seem to be quite similar. But then it appears as though single people are a lot higher as represented. And then interestingly, for people where we don't know their marital status, they're overrepresented in the lost customers. So I'm thinking maybe the lost customers, maybe for whatever reason, they didn't want to maybe they didn't want to be probed. Maybe they did not want to have to give all the personal data. And I'm thinking maybe there were too many questions during sign up. That might be something to look at, sort of in that funnel. Where are we losing customers? Are we maybe asking too many questions? That was kind of my first thought. That's what I would do if I was a bank. Now, let's have a look at income categories. And again, starting with the lowest. So people who are existing customers, they are overrepresented in people who make less than 40,000 a year. And if you remember, that was actually the biggest group as well. Okay. But then lost customers are overrepresented in the categories of a slightly higher middle class. Okay. And they're also overrepresented in high income earners. And then again, we have more people amongst existing customers who are at the higher end of middle class by the looks of it. So again, almost, if you will, at the extreme ends of the spectrum, that's where we have more lost customers by the looks of it. Now, let's have a look at the cards. And it looks really, really similar. There doesn't seem to be any correlation between attrited and existing customers. These are almost like a Venn diagram. They seem to overlap perfectly almost. Okay. Okay, and now if we want to look at continuous quantitative features, so these are not integers, these are values that are, for example, measurements, okay? Floating numbers. So for example, heights, weights, that kind of thing. And these are some of the features that I picked. So we have credit limits, revolving balances and changes, transaction amounts, that sort of thing. And if we want to plot these differences. Now, credit limit. So it looks like lost customers seem to have a low credit limit. So maybe the bank doesn't consider them trustworthy based on a variety of factors. And then again, people with a very high credit limits. Again, we're at these sort of extreme ends of the spectrum. We have a lot of people with a high credit limit who are jumping ship. Okay, and then I would maybe, as a bank, really look at why are we losing these high value customers? What's happening there? Okay, then revolving balance. People with a revolving balance of 0 or very, very small amounts are overrepresented in lost customers, which again makes sense. If I'm a lost customer, I'm not going to store a lot of money in the bank, right? But then interestingly, people with a relatively higher revolving balance are again overrepresented at the higher end of the spectrum. And that makes me think, okay, is it maybe what's going on there? Are these people who are dead and then their money hasn't been collected? Like, I would maybe, as a bank, I would investigate where's that coming from. Why do we have so many lost customers with high amounts at the bank? Now, the amount of change. So generally, if we have a look here, relatively similar. Can't really glean too much from over here. But then if we look at transaction amounts, so it looks as though if we have people with high transaction amounts, they're more likely to be an existing customer, which again makes sense. If they are a customer, they're going to use your bank services. And same thing as well. So if we have a change in the transaction counts, that seems to be an indicator as well. Now, what I also wanted to do is I wanted to look at correlation between features, okay? And I wanted to look at customer groups individually. So let's say you were to build a machine learning model to help you predict whether a customer is about to be lost, or if you want to predict whether or not this person is an existing customer, what you could do is you could look at correlation coefficients. And if you have a value that is 1 or very close to 1, it means it's a positive correlation. So it means that as one variable increases, the other variable also increases. Okay. And then on the other hand, if your correlation is -1 or close to -1, it means that as one variable increases, the other one decreases. Okay. So what I did was I created a little heat map per customer base. Okay. So I created one for tried customers and one for existing customers. Let's have a look at the lost customers first. And basically what we want to find out is are we seeing any values that are very close to 1? So any values that are very light colored? Are we seeing any values that are very close to -1? So any really dark values, if you will. Let's have a look. And so if we, excuse me, if we look at very positive correlations, it seems that customer age and the months on book seem to be positively correlated. So if somebody's a bit older, it looks like they are more likely to have been with the bank for quite a while. And also, let's have a look here, the transaction amount and then the count of transactions, which I guess that's not really surprising. So if you have a large amount of transactions, it also means that your overall transaction value increases as well. Nothing really too crazy or groundbreaking. There are a lot of smaller correlations, for example, transaction count and then the amount of changes that is positively correlated as well. Let's have a look for any negative correlations. Excuse me. So for example, customer age and transaction count is not correlated. The amount of dependence is also not really correlated to the amount of change, the changed amounts. But nothing really catches the eye outside of these bits, to be honest. And then let's have a look at existing customers for a moment. So that's a little bit more expressive, if you will. And like above, it seems that customer age and months on books, so how long have they been with a bank, seems to be positively correlated. So if the person is older, they're also more likely to have been with a bank. And also the transaction amount and the amount of the total count of transactions is positively correlated. And then if we look at negative correlation, so things that decrease as the other one increases, let's have a look. The relationship count, so how many assets do they have in the bank? And that is negatively correlated with the transaction count and transaction amount. So I would maybe look at what kind of relationships, what kind of assets does the bank have that causes this to be the case. Other than that, again, total amount change during the certain frame, and then the count of these items change is correlated, which makes sense. But yeah, to be honest, so if you wanted to, I guess you could build a model. But what I found just looking at this data and segmenting existing and lost customers is that, in a nutshell, if you're a bank and your customer has not used your service in a month or maybe in 2 months, or maybe if they're using your services less than they used to, if you want to keep that customer, if you really are intent on that, you need to take action, basically. And then I also found that women and then people who are at the extreme ends of the education scale and sort of people who are at the extreme ends of the income scale tend to be more likely to churn. And that might be something that I would look at as a bank. Why is that the case? You can, of course, build a model. For me personally, I find that this has been sufficient enough. Okay. All right, now let's have a little look. Any questions? And I'm going to stop this recording just a moment.